Hi, my name is Chelsea Desbiens and my project is on aspirin. In this presentation, I will discuss the history of aspirin, including the discovery of salicylic acid by Edward Stone, the chemical and physical properties of aspirin, and also the medical uses and side effects. The active ingredient in aspirin is salicylic acid. This can be found in plant extracts, such as the bark of willow trees. While aspirin was only first produced over 100 years ago, salicylic acid has been used since the time of the ancient Egyptians. The salicylic acid from the plant extracts helped in relieving headaches and pains and reduced fevers. In the year 1763, Edward Stone at Oxford University was the first to successfully isolate salicylic acid. This natural form was known for its terrible taste and causing stomach aches. It was later in 1853 that a French chemist, Charles Frederick Gerhardt, first prepared ASA with the addition of acetyl to salicylic acid. Felix Hoffmann worked to create a more stable version of ASA in 1897, making it easier on the stomach. By 1899, aspirin was officially trademarked and sold around the world. When placed in a solution containing any acetates, carbonates, citrates, or hydroxides of the alkali metals, aspirin will decay quickly. It is stable in dry air, but will hydrolyze to acetic and salicylic acids if it comes into contact with any moisture. Hydrolysis will take place rapidly if combined with alkalis. This will result in the aspirin to turn into a clear solution of acetate and salicylate. Aspirin, a white crystallized substance, is derived from salicylic acid. It is also a weak acid. Polymorphism is defined as the number of different crystal structures that can be formed. Aspirin was known to only have one form up until the year 2005. This is when a second crystal structure was discovered. However, the second form is only stable at 100 Kelvin and then returns to Form 1. Form 1 consists of two salicylic molecules forming centrosymmetric dimers through the acetyl groups with the methyl proton to carbonyl hydrogen bonds. In Form 2, each salicylic molecule forms the same hydrogen bonds with two neighboring molecules instead of one. The synthesis of aspirin is an esterification reaction. Salicylic acid is treated with acetic anhydride, causing the hydroxyl group to become an ester group. The mechanism yields aspirin and acetic acid. Typically in this reaction, sulfuric acid is normally added to the reaction to act as a catalyst. Aspirin is grouped as a non-steroidal anti-inflammatory drug. However, it possesses a different mechanism of action compared to others in this group. The drug can help against pains and headaches, but is inferior when compared to other painkillers. Aspirin is typically unsuccessful against pains such as cramps and bloating. However, when combined with caffeine, aspirin supplies more relief. Aspirin helps to reduce a fever by means of its prostaglandin system. This inhibits cyclooxygenase. It can also act as an anti-inflammatory agent and treats things such as rheumatoid arthritis. Peter Slade at Oxford University was the first to study the effects of aspirin on heart attacks and strokes. This is possible because of aspirin's abilities to keep blood from clotting. Research is also being done on whether aspirin helps prevent cancer or keep people from dying from cancer. This effect has mainly been associated with colorectal cancer. Nausea, vomiting, stomach pain, and heartburn are the more common side effects associated with aspirin. These can be managed and are likely to go away in time. While the possible serious side effects, such as hives and loss of hearing, are rare, they should still be addressed immediately.